All right, so today is the last day of factoring that we're gonna do. This is all of the specialty things. So some of these you may have seen and some of them you may not. That's okay, we're gonna go over it now if you haven't seen it. The first one is called difference of squares. And it is square, so difference of squares is whenever you have two perfect squares. And what do I mean by perfect squares? I mean, there's like 1, 4, 9, 16, 25, ... so on. Those are all perfect squares. So if you have two perfect squares that are being subtracted, you take the square root of the first term, and that'll be your A, and the square root of the second term, and that will be your B. And so you have A plus B times A minus B. Okay, let's just do one. I think it might make more sense. So I like to write it out. What is the A term? What is the B term? It seems to help a little bit. So A. My A term is the square root of x squared. So what's the square root of x squared? Just x. My B is the square root of 25, which would be 5. So when you factor this would be x plus 5 times x minus 5. Because that's what the formula is. And if you were in my classroom right now or you're watching this, look up at the front of the room, and it is difference of squares is on the wall. So you should find it somewhere in the room. Okay, and it'll be up there for the quiz and the test. All right, so difference of squares here, same thing. Are these perfect squares? Both of them? Yes. Are they being subtracted? Yes. If they're not being subtracted, then you can't do it. Okay, so we've got what would be our A. The square root of 16n squared would be 4n. And our B would be the square root of 1, which is just 1. So this will be 4n plus 1 times 4n minus 1. Boom, you're done. Okay, this one's a little bit harder. Are these two perfect squares? Yes, and they're being subtracted. So what would your A be for this one? The square root of 25v to the fourth would be 5v to the second. Because 5v squared times 5v squared to give you 25v to the fourth. What would your B be for this one? 4w. So this would be v squared plus 4w times 5v squared plus 4w times 5v squared minus 4w. All right, another one. Your A for this one, they're both perfect squares, yes. The A would be 8x. The B would be 3y squared. So this would be 8x plus 3y squared times 8x minus 3y squared. Okay, I'm going to give you one more off to the side. What about this one? Let's do 16x squared plus 9y squared. Okay, what would this be? Well, this is a trick question, okay? Yes, the first term is a perfect square and the second term is also a perfect square, but because of this plus sign, if you have one like this that has a plus, you cannot do it. Only subtraction problems, okay? So just know this right here is unfactorable. Okay, so that's as far as you can go. All right, so now this next one is not on my wall because it's a little less important. You don't use it as often, and there's a workaround, but if you can remember this, it might like speed up some things later on down the road. So A plus B squared equals A squared plus 2 times A times B plus B squared. So what you do is you square the first term, square the last term, multiply them together, and double it for the middle term. So let me just prove to you that this works. So A plus B squared could be written like this, right? So I'm going to work it out. So that would be A squared plus AB multiply that out, and it would be AB plus B squared. Combine your like terms in the middle. That would be A squared plus 2AB, because AB plus AB is 2AB, plus B squared. So that's just proving to you that it works. So if you forget this trick is not the end of the world, you can always just distribute it out if you need to. Doesn't matter. Okay? All right, but now let's do the trick. So you take the first term and you square it. So 4x squared. You take the last term and you square it. So positive 25. Then you multiply them together. 2x times 5 is 10x, and you double it. So that would be positive 20x. Okay? Let's do C right below that. Oh, actually, no, we won't because it has a minus sign. All right, we'll go to B. All right, so the same thing. This one has two. You have an addition version and a subtraction version. It works either way. So how I think of it, it's very, very similar. So if you have it's still the first term squared, and the last term, what is negative b squared? Well, that's going to be positive b squared. Okay, and then the middle term is still the same. It's negative, you double it and multiply them together. So a times negative b would be negative ab, and double it would be negative 2ab. Okay, so for this one, you would square the first term, so that would be 9x squared. Square the last term, what's negative 4y squared, or negative 4y squared? It would be positive 16y squared. Multiply the two together. 3x times negative 4y is negative 12y, and double it. So negative 24xy. Okay. Now this one, now I'm giving it to you as a trinomial. I want you to do the reverse and factor it, but using the shortcut. So, is your first term a perfect square? Yes. Is your last term a perfect square? Also yes. So our a, the square root of the first term would be x. The square root of the last term would be 3. Now here's where you check. Is this middle term, these two multiplied together and doubled? So x times 3 is 3x, doubled would be 6x. Well, this is a negative 6x, so what do I need to do? I need to make this a negative 3. So x times negative 3 doubled would be negative 6x, so it does work. So this would be x minus 3 quantity squared. Or if you wanted to do the old-fashioned way, what multiplies to be 9 and adds to be negative 6, negative 3, negative 3. That's what you did on the previous homework. Okay, another one. Is the first term a perfect square? Yes. That square root of that would be, so your a would be 3x. Is the last term a perfect square? Yes. Is the middle term, those two doubled, or multiplied together and doubled? And the answer is yes. So then this would be 3x plus 1 squared. Okay? Ooh, we're getting crazy here. Now, E. Is the first term a perfect square? Yes. That would be 2v squared. Is the last term a perfect square? Yes, that would be 3w. Is the middle term, those two multiplied together and doubled? Yes. So this would be 2v squared plus 3w squared. Okay. Another one. Even worse, that's okay. Is the first term a perfect square? Yes, it would be 4x squared. The last term is a perfect square as well. It would be 3y squared. 4x squared plus 3y squared, or times 3y squared. That would be 12xy, x squared, 12x squared y squared. Doubled would be this. So it does work. 4x squared plus 3y squared squared. Lots of squareds. One more off to the side just for fun. If I gave you one that was this, 4x squared plus 9xy plus, let's do 9y squared. Let's factor this. Is your first term a perfect square? Yes. That would be 2x. The last term is also a perfect square. That would be 3y. Now is the middle term, those two multiplied together and doubled? The answer is no, that is not what that is. If this was 12xy, that would work. But as it's written right here, you can't factor this. So if you came up to this, this would be unfactorable. I just wanted you to be able to see one that's unfactorable just so you are aware. All right, the last part of this video is about sum or difference of perfect cubes. So there's two formulas. This is also on the board at the front of the room, so check it out. Okay, so the last two parts were about perfect squares and square roots and things. This is perfect cubes. So it might be handy to have the first few for sure memorized. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 is 125. Usually the first 5 is all you'll usually need, but you will have a calculator for this. So if they get hairy, 6 squared is 216, I believe. I think that's all we need for this one. Okay, so this works as long as both terms, it's a binomial. They both have to be perfect cubes, so some version of those numbers. And if they're being added, we're going to use this. It is kind of gross, but it's all right. It's long. If they're being subtracted, then you do the second formula. And again, both of these are on the board because I know they're long and kind of gross. Okay, so these ones, are they perfect cubes? Yes. Your A would be 5, your B would be x, because we're talking cubes. So they're being added, somebody plugging them into that first formula. So this would be 5 plus x, parentheses, 5 squared minus 5 times x plus x squared. Okay, I intentionally, oh, actually, I'm just gonna, hold on, that's the next problem. All right, so this is, let's clean this up a little bit. On your test and quizzes, if you have something like this, I do want you to clean this up, 5 squared, because you can, and you just need to. Okay, so I'm just gonna clean up that last bit, so that would be 25 minus 5x plus x squared. I think that's good. So that is now factored. Okay, let's do another one. Another addition problem. So actually we're gonna skip B, go to C for the moment. We'll go back to it. This is a subtraction one. Okay, is the first term a perfect cube? Yes. Is the second term a perfect cube? Also yes. The cube root of 64. Some of you may be tempted to say 8, but we're in cube rootville, so we're not talking about square roots. It is 4. That's a common mistake people put. They'll put 8 right there because they're thinking square roots. So this would be 4x. All right, let's plug this into my formula. So I would have, it's the subtraction formula up over there on the right. So it would be 3 minus 4x times 3 squared plus 3 times 4x plus 4x squared. Okay, now this is what I was talking about in the last one. I intentionally wrote this wrong on purpose. There is a piece that I wrote wrong, and you may think it's the 3 squared. No, it's not that. It's this. Let me, oh, wrong button. It is this right here. So based off of how I wrote that, that is 4 times x squared. Really, I should put parentheses around it because there is a difference between 4x squared and 4x squared, right? This one is just 4x squared. This one would be 4x times 4x, which would be 16x squared. So you really do need parentheses around that whenever you're doing that if it's more than one thing. Okay? All right, so let's clean this whole thing up. So that would be 9 plus 12x plus 16x squared. Done. All right, 2 more, then we're done. All right, are these perfect cubes? The answer is no. Then what do you do? Okay, so there's something I haven't done yet in this video at all, which I should have, but it's okay. You always check whenever you're factoring if there's any what. The answer is a GCF. Don't forget the GCF thing. Is there a GCF of both of these? The answer is yes. It is 4. So this would be 4 times 32x cubed divided by 4 would give you 8x cubed, plus that would be 27, I believe. Now, are those two things perfect cubes? The answer is yes. So now we're going to factor it, no big deal, and it's just going to have that 4 floating around out front. Don't forget about it. Don't let it fall off. So my A for this would be 2x. My B would be 3. So I get to plug it in that big formula. It's okay with the 4 floating around out front. Actually, let's do this in a different color. So it would be 4 times A plus B, so 2x plus 3 times 2x squared, and I need to put parentheses around that because it's not just an x, minus 2x times 3 plus 3 squared. Parentheses for days. Let's clean it up. All right, so that 4 is still going to be floating around outside. I'm going to drop all that down because you can't do anything there. 2x squared would give you 4x squared. Negative 2x times 3 would be negative 6x. Plus 9, close your parentheses. I think we are done. Yes. Okay, last one. Are these perfect cubes? The answer is no. Okay, so is there any GCF you can factor out in order to get them to be perfect cubes? Looks like 2. If I factored out a 2, that would cause that to be 125, and I know that's a perfect cube. So let's do that. That would be 125 minus 216u to the third. All right, cool. So now they are both perfect cubes, so let's just finish it up. Your A is 5, your B is 6u. Okay, so now let's do it. That 2 is still floating around out front. We got to use the subtraction formula. So it would be 5 minus 6u, and then 5 squared plus 5 times 6u plus 6u quantity to the second power. Close those parentheses. All right, now that that's looking really gross, let's finish it. So clean it up. That would be 2 parentheses, 5 minus 6u, close, open parentheses, 25 plus 30u plus 36u squared. Close parentheses. All right, that is it. Thanks for watching day 3 of factoring. Hope you have a great rest of your day.